physics. If you are talking about resistance, still go back to resistance now and say that if you're talking about when resistors are arranged in series, it is ROT equal to R1 plus R2 plus R3. So if maybe you have a resistance of 1 ohm, 2 ohms, 3 ohms, and you are told to find the equivalent resistance, you just add them together to give you 1 plus 2 plus 3, which is going to give you 6 ohms. Then when you are talking about resistance in parallel and you are given 2 ohms and 2 ohms together, resistors of 2 ohms and 2 ohms, you're going to give 1 over ROT equal to 1 over R1 plus 1 over what? R2. And this will give you 1 over 2 plus 1 over 2, and 2 into 2, 1 times 1, 1, 2 into 2 again, 1 times 1, 1. And 1 plus 1 is 2, you have 2 over 2, 2 here, 1, 2 here, 1. What you have here is 1 over 1. And remember that is 1 over ROT that you have here. So if you have 1 over ROT, is equal to 1 over 1, which is, you take this ROT up, and you take this one up, and you bring this one down. So it's still going to give you ROT is equal to 1 ohms. So whenever resistors are arranged in parallel, it's going to give you the same thing. So let's say we try something like this now. Another example, resistors in parallel. Let's see if we can get a question in that regard. That has to do with resistors arranged in parallel. Okay, let's say resistors 2 ohms, 3 ohms, and 5 ohms are arranged in parallel. So remember, 1 over ROT equal to 1 over R1 plus 1 over R2 plus 1 over R3. So meaning that what we have here is going to be 1 over 2 plus 1 over 3 plus 1 over 5. What's the LCM of 2, 3, and 5? I think it's going to give us 30. 2 into 30 will give us 15. 15 times 1, 15. 3 into 30 is 10. 10 times 1, 10. 5 into 30 is 6. 6 times 1, 6. So if you have 15 plus 10 plus 6, it's going to give us 31 over 30. So when they are arranged in parallel, we're having 31 over 30. And remember, this is 1 over ROT. But like I said, we're looking for ROT. So ROT goes up, 30 goes up, 31 comes down. So this will give us ROT is equal to 30 over 31 ohms. And when you check this, it's going to give you 0.97 ohms. Use your calculator to get this. You observe that this is going to give you 0.97 watts ohms. Now, so when they are in series, if you have 2 and 3, you just add them together to give you 5 ohms for the resistance. But when they are in parallel, it's going to be 1 over 2 plus 1 over what? 3 equal to 1 over what? ROT. You find the LCM 6, 2 into 6, 3, 3 into 6, 2. So now you now have 5 over 6. And you know this is 1 over ROT for parallel. So 6 goes up, 5 comes down. So it's going to give you 6 over 5 is equal to what? ROT. And ROT is equal to 1.2 watts ohms in that regard. So whenever you're talking about parallel, you know there's going to be a huge difference. Now take note of these formulas which I gave you in the video before. Now take note that of the formula P work is equal to QV, V equal to IRO, and V equal to IRO, and we have that Q equal to IT. So let's place this Q here, Q into Q. So if you place Q into Q, we have W equal to IT times V, and W is equal to IVT, which is our first formula 1. Then I said we can also have V equal to IRO. So if we have W equal to that W equal to IVT, we can also write that IVT. Then we can also have that I times V is IRO, so write IRO times T, and this will give you I times I, which will give you I square ROT. And so this is our 2. So W equal to I square ROT. Then the next one, if V is equal to IRO, then we can also make I the subject, and this will give us I equal to V over RO, and this will give you I times, we already know that I is V over RO, so just write V over RO times V times T. So work is also equal to V squared T over what? RO. This is our equation 3. Now if we have this, W is equal to IVT, W is equal to I square ROT, and W is equal to V squared T over what? Arrow. Now if we have these three formulas, we can now say that power is equal to work done over what? Time. So that means all this work that we got before, we just divide them by time. I square ROT divided by T, and V squared T divided over arrow divided by what? T. T here 1, 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 T here 1. So what do we have now? We have power is equal to IV, power is equal to I square arrow, and power is equal to V square over what? Arrow. Now, you also take note that I said work can also be expressed in terms of potential energy or kinetic energy. So that means work can also be expressed in terms of heat. So if this place you are asked what is the heat energy, you can use any of these formulas to calculate heat energy, and this heat energy is represented as Q. So we can say that work is also equal to Q. We can also say this is equal to what? Q. So this work here now can also represent what? Heat energy. You take note of this. So let's see if we can solve some questions. Now let's check out this question. The question says find the resistance of a wire of length 0.65 meters, radius 0.2 millimeters, and resistivity 3 times 10 to the power 6 ohm meter. Now you take note, before I start solving this, you take note that resistivity is equal to rho L over A. That's a resistance, sorry, this resistance is equal to rho L over A. This rho you are seeing here represents resistivity. Now they told you that the resistance of a length of wire, so they gave you the length of wire to be 0.65 meters. They gave you the radius. That's arrow to be 0.2 millimeters. 0.2 millimeters. Now they gave you the resistivity rho to be 3 times 10 to the power minus 6 ohm meters. Now they are not telling you to calculate the resistance. Calculate the resistance. Now you see this place here. This one represents area. Here represents area. Here represents length, and here represents resistivity. So resistivity. So what you just do now, let's rewrite the formula again. Arrow is equal to L over A. Now we have length already, we have radius, but now if you observe this formula very well, is there radius? No. But you take note that all the wires we always talk about, all the wires are usually in this form, like a cylinder. So since it's like a cylinder, the area of a circle is pi r squared. So we can use the area of the circle. But now you observe that the radius is 0.2 millimeters. Now you take note that we will not use 0.2 millimeters, but rather we'll convert these millimeters to meters. Now remember 10 millimeters make 1 centimeter, 10 centimeter make 1 decimeter, 10 decimeters make 1 meter. So that means 1000 millimeters will make 1 meter. So that means 0.2 millimeters will give us x. That means 0.2 millimeters will give us x. So we're going to cross multiply, and we have that x equal to 0.2 divided by 1000, and this will give us 0.2 times 1000, which is 0.2 times 10 raised to the power 3. This is 2 times 10 raised to the power minus 1. 2 times 10 raised to the power minus 1 times 10 raised to the power 3. 2 times 10 raised to the power minus 2. 2 times 10 raised to the power minus 2. Okay, this is going to be minus 3. Yes, 2 times 10 raised to the power minus 4. Yeah, because this is divided, it's supposed to be divided by 1 over 1000. Yes. So from here we now have 2 times 10 raised to the power minus 4. So radius is 2 times 10 raised to the power what? Minus 4. And remember that area is equal to pi r squared. So this is going to be 22 over 7 times 2 times 10 raised to the power minus 4 squared. So let's see what we'll get out of that. I got the value of radius to be 2 times 10 raised to the power minus 4 meters. Then I came here, replaced this A, then from here got my value of area, because area is pi r squared, 22 over 7 times this squared. And I got area to 1.25 times 10 raised to the power minus 7. You know, this place is area now. Now we've already gotten rho to be this, and we've gotten L to be 0.65. Now after doing this, we get 15.6 ohms, or 15.5 watts ohms, and that's our answer, 15.5 ohms. The question said a headlamp of a car takes a current of 0.4 ampere from a 12-volt supply. The energy produced in 5 minutes is now you observe that they gave us current, which is I. In this case now they gave us voltage, which is V, and they gave us time. Now they gave us current, which is I is equal to 0.4A. They gave us voltage is 12 volts. Then they gave us time to be 5 minutes. Now anytime you are solving this, you need to always convert your time to seconds. So 5 times 60 give us 300 seconds. So anytime you are solving this, you always convert to seconds. Now you come back here and check. It said calculate the energy. I told you that energy, which is heat, is also the same thing as work. So we observe the parameters we have here. IVT. The parameters we have here is what? IVT, I square RT, and V square T over R. Now in this place you have IVT. I and V are common, and T is also here. So we can use work is equal to IVT here. So IVT will give us 0.4 times 12 times 300. And 0.4 times 12 times 200. So let's check it out. Means if we use the 0.4 times 12 times 300, it's going to give us 1,440 joules. And 1,440 joules in that aspect. Now observe this question. Now I said two resistors, 5 ohms, can be combined with an equivalent resistance of. Now if you combine 5 ohms, they didn't tell you if it's series or parallel. So 5 plus 5 will give you 10. Then 1 over 5 plus 1 over 5. And now bring it up again to give you 1 over 5 plus 1 over 5, give you 2 over 5, 5 over 2. So it will give you 2.5. So the answer is supposed to be A and C. So that's question 3 here. You observe this very well. So let's see if we can try another question around here. Now observe. Now listen, we're talking about resistivity is equal to L over A. Now if they ask what are some of the factors that affect electrical resistance, the first one is the length of the conductor. The next one is the area of the conductor. The length of the conductor can affect the electrical resistance. The other one that can affect the electrical resistance is the area of the conductor. And the next one that can affect it is the temperature of the conductor. So the temperature of the conductor can also affect. So you have the temperature of the conductor, the area of the conductor, and the length of the conductor. These are some of the things that can affect it. So if they ask you, you have the length, the area, and the temperature. These things are very important. These are the 3 things that can affect electrical resistance. So the length of the wire, the strength of the wire, that's the area, the temperature of the wire. Then also we can also talk about the type of material. We don't know the type of material. The type of material involved can also affect it.